Hello and welcome to another session of GeogRocks with me and Mr Squawk. Mr Squawk. Today we're talking about rocks and different types of rocks because I love rocks. The thing about, you've got to say, what is my best kind of music? Okay, you know all my jokes. Rock music, oh yeah. What's my favourite kind of horse? Oh, yeah, okay, rocking horse. You know that. And what's my favourite film? Rocky. Okay, you know all my jokes. Okay, I won't tell any more. I don't think you appreciate my jokes anymore. But we're going to learn 3 big words today. Important words of the different types of rock. Thank you very much. 3 kinds of rocks: sedimentary, metamorphic, and igneous. They are the 3 buckets of rock types that we geologists use to put each rock into. Igneous at the bottom, metamorphic and sedimentary. Meteorites. Meteorites, well, they come from outer space, so they're not really one of these. Okay, so it's not all kind of rocks. I know, these are earth rocks, rocks we find on earth. Right, we are going to start with sedimentary. Shall we start with sedimentary? Sedimentary. Sedimentary rocks are generally in water. I know, that doesn't look very nice. No, I'm not going to drink it. It's not beer. This is actually from a river. It looks very dirty, but actually it was even worse when I collected it. What you'll see though, I've allowed it to settle for a long time now, for a few days, and you can see it's got a line in it. It's got a layer. Don't think you can see it all that well, but there's a layer you can see on there of black silt, and then there's sand, and at the bottom is grit and pebbles. If I leave this long enough, it'll become a proper rock, a sedimentary rock. Yeah, we're not going to wait that long. Yeah, about 1 million years, so we won't wait that long. But that is the way a sedimentary rock is made. There are 2 kinds of sedimentary rocks, though. There are those which are made in rivers and in oceans and in seas like that, and they will form sandstones and siltstones. Sandstone and siltstone. These beautiful stones like this. Oh, it's a big heavy one. They make buildings out of this because they are so good for making, you'll find you can't eat it. They make lovely stones for building churches and big buildings. So those are sandstones and siltstones. And then there are also sedimentary rocks which are chemically made, or made from small animals which have fallen onto the floor, the bottom of an ocean. And you can see this one has got shells on it. And over time those shells will be transformed to give us chalk and eventually limestone. Chalk and limestone. So wherever you've got some creatures and which are slowly turning into rock like this. This is about 1 million years old, this one, and you can still see their shells in there, but over millions of years this will turn into a rock like limestone or chalk, and those are all sedimentary rocks. So sedimentary rocks, they are generally in water, although they can also form in deserts because big sand dunes can deposit sand as well. One thing about sedimentary rocks is that they are brilliant for fossils. If we're looking for fossils, these are the kind of rocks we look for. I've got one here which I found quite close by. You can see it's almost shaped like a wave, and it has layers which we call strata. This one breaks apart beautifully. Thank you for holding it. Sorry, it's very heavy. You're going to drop it. Okay, don't give me a drop. But it can split apart along these strata. It's got layers in it. And on those layers, you can sometimes find fossils. Yeah, nothing to eat in there. In fact, this one has got little indentations, little drops, marks at the top where raindrops will have formed. So sedimentary rocks are great for finding fossils. They are generally from sand and silt and other grains like that, or they're from other precipitates like small animals. Now, because they're in layers, something fantastic can happen with them. Okay. Something brilliant can happen with them. We got layers like this. You're going to hold it for me. We know you did it though. Okay, hold it tight there in your blick. Okay, you got it there. Now you can see there, these are like layers, and because they're in layers, they can bend and they can fold. We call them folds. So there is a layer of rock. If we can pretend these are rocks, that you get nice bends in. Yeah, that's like an S bend. S for squawk. Actually, it's the other way around, isn't it? These are, there we are. We can bend it that way. You can break them as well. So we'd have breaks, and we call it a fault. If in fact the rock breaks entirely, we can get rocks moving and being broken. These layers can be broken. No, it's not my fault. It's called a fault. Yeah, it's nobody's fault. It's just a rock fault. That's all it is. So that is sedimentary rock of layers. Now what happens, as we go into our next rock type, these rocks can get squashed together, and they can get squashed and squished and squizzled, and they can change into something entirely new. As they get more squishled, so they get a whole different rock type. They've been squishled together so much, there's no more layers in there, and we get a whole new rock type appearing, which we call metamorphic. Metamorphic. Meta, because meta means change, and morphic is form. So metamorphic is a whole different rock type. Metamorphic. And we get beautiful rocks. For example, where is a nice example of a metamorphic? Oh, this is called schist. Schist. That wasn't a swear word. Schist. Oh, it wasn't a swear word. Schist is the name of a rock. You can see how it's glinting and shining in there. It's got what we call foliation or cleavage. So it's got layers in it, but they're not at all like the big sandstone layers. They're very thin, and what can happen is that these layers can run into each other like that. I know it looks like you can eat it, but this is not a rock you can eat, this one. These foliations are tightly folded in there because this rock has been squished and squashed together over time, and it's given us new minerals. Great thing about these is that you get the thinnest rock in the world from here. And this is one I got from Tanzania. It's called mica. This rock is the thinnest rock ever. You can actually look through it. It can be so thin. I wonder if I've got a piece we can actually look through. It's very, very fragile. Oh, there you are. I can see you, Mr. Squawk. I can see you through the rock. Yeah, there you are, through it. You can see. It is so thin, this rock. It's very, very delicate, this mica. And it's this mica which gives us the glitter on this schist. Oh, I said schist, not anything else. So this is one kind of metamorphic rock, and we have another one called gneiss, which you are sitting on. Gneiss. N-E-I-S-S, not nice as in that's a nice thing to eat, but gneiss as in it's a gneiss big rock. Now, the thing about metamorphic rocks, they can also have lovely minerals appearing. So the metamorphic rocks sometimes can have some shiny minerals beginning to appear, which we can look for ore. Things like gold might even appear and things like that. Whereas sedimentary rocks won't have that, but sedimentary rocks are very good for water. So if we're looking for water or coal or oil, we would look in sedimentary rocks. I love them because I work in water. So sedimentary rocks are good for that. Then we got metamorphic. Now we're going to go even deeper into the earth, right into deep beneath the continents where the mountains are forming. We have a new kind of rock, which is not just changed, but it's under really high temperature. And for this, I'm going to show you how it looks like, and it looks like porridge, basically. Yeah, you can chew it, but you're not going to get anything out of that. It's Play-Doh. It's like porridge, and we call it igneous rock. Igneous. An igneous rock is igneous. An example of igneous rock is granite. It doesn't have any layers. It's also not very tasty to eat. But it sometimes has wonderfully big crystals, because underneath and deep down in the earth, you've got time for crystals to form. Here's a big square one of feldspar, a big square crystal. We have other crystals of different colors which can form. Here's a beautiful pink ones. We have blue one here, because in igneous rock we can get holes, gas holes in them, and the crystals can grow to a fantastic size, really big size. So this is fluorite, and it comes from Cornwall, and it's very, very heavy. Yeah, and it's quite hard, but the shapes on it, look at the facets, the edges of those crystals, because it's had time to grow slowly deep down in the earth's crust. So igneous rock occurs deep down, firstly as magma. No, not mama, magma. M-A-G-M-A, magma. Yeah, and it also won't taste any good as well. So magma. We have magma, but if it gets to the surface, then something amazing happens, because it pops out on surface through a volcano. And what do we call it if it comes out? We call it lava. Stop it. Lava. Now I've got a lovely bit of lava here. Oh, this is a basaltic lava, and you can see it's oozed out like porridge, picking up little bits of rock around it on the way. And this can flow right across landscapes. This is a kilometer thick bed of lava from South Africa. Sometimes it can be explosive, and it can shoot out the top of a volcano as little globules. And we call these lava bombs, because they'll shoot up in the air, and you've got to be very careful walking around near a volcano. This is really why you don't want to be too close to a volcano, because of the lava bombs which might be falling around you. So you get lava bombs which come out. Sometimes it comes out so quickly that we have no crystals at all, and it looks like glass. This is obsidian, and it's very black. People used to make jewelry obsidian. Out of obsidian. It was very sharp. I think we could almost shave with it. I think I could shave your hair with it as well. Okay, I won't. So that is igneous rock. With igneous rock we get some lava which is so light it can float on water. It's called pumice. And you might find your mum might have some in the bathroom, because it's so nice to clean your skin with. Yeah, pumice. I know my skin is past that point. I don't think it'll do me any good, any help, I'm afraid. Right, so that is lava. That is igneous rocks, and that is done metamorphic rocks. So are you going to remember all that? We've done quite a lot of rocks today, haven't we? But that is very important. So when we're looking for rocks and we are outside, it's not just enough to go around and pick up a rock and say, oh, look at this rock, I found myself a rock. You want to also look around and say, did this rock come from the place where there's layers? Are these layers very flat? Are they bent and folded? Because that gives us a very important clue on where your rock might have formed and what kind of rock it is. It's very important when it comes to identifying rocks. And you also now know where you're going to go if you're going to find some fossils. If we want to find a dinosaur fossil, it's no use looking in igneous rocks, because that is just like porridge, and that will have burnt and bubbled anything that's in there. It's no use looking in metamorphic rock, because that's been completely changed as well. We've got to look in sedimentary rocks, and very carefully. Sedimentary rocks, we can open them up very carefully and look inside, because every rock tells a story about the earth, a story about us, as we've been discovering. This is one of my favorite rocks. It comes from Morocco and looks very boring, but if I open it out, just have a look inside that beautiful rock. This is inside an igneous rock, and there was obviously a big, wonderful gas hole inside, a void, as we say, and these crystals of amethyst have grown. People love collecting this purple crystal, and that's inside a rock which otherwise people weren't even looking at. So when you're next out and about, make sure you look at the rocks around you, and not just the rocks on the ground, but also what it looks like around. Are there layers, or is it all one big bump of porridge, or is it twisted and folded? We want to understand the world around us, and that's what rocks helps us do. Tells us our story, okay, and your story as well, okay, and dinosaur story, yeah, everybody's story. And for example, when I'm out looking for water, I need to know what kind of rock I'm looking for. If I'm looking for gold, I need to know what kind of rock I'm looking for. So knowing your rocks is very important. Okay, guys, hope you had fun. I'll see you next time, and keep looking for rocks, please. Bye-bye from myself and Mr. Squawk. Bye-bye. Yep, we finished now. Rock on, everybody. Okay, that was silly as well. Okay, I admit. We'll just say bye-bye, shall we?